Symmetry of functions. An even function has line symmetry about the y-axis. This occurs when all of the terms of the polynomial contain even exponents. For example, y equals x squared minus 4. Remember to examine the degrees of all terms, including constants. They have a degree of 0, which is even. If the function is an even function that is symmetrical over the y-axis, then f of negative x equals f of x. For example, given the even function f of x equals x squared plus 5, plug in negative x. So that becomes negative x squared plus 5, which is the same thing as x squared plus 5, since a negative x squared is positive x squared. Notice f of negative x equals f of x. Therefore, f of x is symmetrical over the y-axis, as we would expect for this even function. All functions with even exponents are not even functions. For example, given the function f of x equals x plus 5 squared, we plug in negative x, and then we simplify that, and that becomes 5 minus x squared, which is not the same as x plus 5 squared. Notice f of negative x does not equal f of x. Therefore, f of x is not symmetrical over the y-axis, as we would expect for this even function. An odd function is symmetrical with respect to the origin. This occurs when all of the terms of the polynomial contain odd exponents. For example, y equals x cubed. Remember to examine the degrees of all terms. If the function is an odd function that is symmetrical about the origin, then f of negative x equals negative f of x. For example, given the odd function f of x equals x cubed, plug in negative x. That gives us negative x cubed. Simplified, that is negative x cubed. Notice f of negative x equals negative f of x. Therefore, the function is symmetrical about the origin, as we would expect for an odd function. All functions with odd exponents are not odd functions. For example, given the function f of x equals x minus 2 cubed, we plug in negative x. That becomes negative x minus 2 cubed. Simplified, that is negative x plus 2 cubed, which is not equal to x minus 2 cubed. Therefore, f of x is not symmetrical about the origin, as we would expect for this odd function.